Hello and welcome to another free code session. My name is Jason Bach, and I'm pretty much done with this story here. I'm going to commit it as soon as I go through a couple things on camera with you. It's all seeming to work. I did actually figure out how to not have this be a lambda. Let me go into the code and show you what it does. Okay, we have the case where we have a object that has a child object. And so if you go look at the set state, the get state, I just do load property. So you call read, that returns you the object back, and it will also return null if there's a null. And so in the case where this will in all likelihood not be null, I basically always just put an exclamation point there and just say take whatever it is and return it back. And it works. It's fine. It's fine. So that works fine. And then you don't have the lambda, and then it seems to read a little bit nicer. So everything's working now. I did create a couple more benchmark tests. I've got 2 of them in a results file now. So that's created. So I'll keep working on that. As you can see, it's pretty much the same as it was before with the base example, and then also I added a collections example, which basically makes a collection of 100. And you can see that it's interesting. The ratio actually is a little bit better when you have more. I don't know why, it just is. And the allocation is also much nicer. So there's other cases I got to handle, like what happens if you make a list and then you delete some, and then does that serialize correctly? I still got to get tests around that. But again, this is feeling good. This is feeling nice. So yeah, I'm pretty happy with this, and I think it's time to move on and do something else. There was one other thing before I move on to something else, which is I was testing out the case, what happens if you have nullable child members in a list. And as I found out, I forgot I actually created an issue in CSLA. It's this one. So the problem is that CSLA doesn't use nullable reference types, and it really should. At this point, if you're creating a library in modern.NET, you should have things annotated correctly and also be defensive against nulls. So the problem is right now is that even if you say I want to have a list that could have nullable child members in the list, it doesn't support it because it will assume that the thing you're giving it is always not null. And so it will try to call members on it, and then you get null reference exception. So this is something that hopefully will get addressed in the future. But for right now, you have to have non-nullable references in your list. So that test really didn't matter. I made a test then just to say what happens if you have duplicates, just to make sure that works. And that works, and that has basically the same performance characteristics that you saw with the other test that I did with collections. So what I'm going to do is I'm going to close this out, and then we're going to move to another issue. So I'll be right back. Okay, the next issue that I'm going to work on is this one. So this is an idea where you could have something like a struct, for example, some type that isn't a stereotype. And right now, both the mobile formatter and my formatter won't handle that. It will just error out. And so it'd be nice if there was a way to say, I can handle this specific type. Let me take care of it. So what I want to do is do something where there is some thing that you would register, and hopefully you'd register it as a singleton, but doesn't matter. You just register something of this type. And yeah, I didn't think about that. That should be okay. Because, yeah, you want to register serialization types. The thing that you want to do, though, is say, here's a key, and I want to then give a pair of serialization and deserialization delegates. I'm going to have to play with this as I create it. The point, though, is that you'd register something into your container, and then the context would get an instance of this, assuming it's there. You may not have done that, and that's fine. You don't have to do this. So I got to be defensive around the fact that you may not have actually created it. Okay. So what this would do is basically have like a read custom or a write custom method. And you'd specify the type that you want to either write or read, and that would turn around and just call this the machinery in this. And if you didn't register something, or it would just fail and say, nope, can't do that. So let's build this and see what happens. So we got the branch. Let's call it custom types, custom serialization types, or just custom serialization. Naming's hard. Naming is hard. Yeah, what name do I want to call this? I don't know. Custom serialization support. Custom serialization. You know, we'll just call it this. It's fine. It's fine. It's fine. Public seal class. Okay. So what we want to give this thing is custom serialization. It's probably a dictionary of a type and then a pair of things. What is the pair of things? A serializer needs to take what? What does it need to take? I would think that would be an action. This is not as easy as I thought it was going to be. And maybe I should have done this on a Monday morning, but that's okay. So we want to say for a given type. What we actually want to say is for a given T, but we can't have T for every single thing in there. It has to be something where my brain is struggling at this at the moment. Yeah, we want to have serialization types where it's a T type. My brain is just not working right now. And we want to say something like public of an action of a T type. How did you assume that was going to be what I wanted? Because it's scarily close, but way off. And then we want to have a binary writer because you need to do that. And then this is a func where you're getting the binary reader and you return a T type. That's what you want to return. Try, get, customizations. I don't know. For a given T type, right? Okay, so we do that. Let's take this off of here, okay? And so we say that, okay, right here we just return null. Okay, cool. All right, now I think brain working, I think. Because what we can do here is this is where you're doing the public custom serialization, where you're giving the dictionary where it is a type, and you want to have crap. I want to have, let's say, a private read-only dictionary of a type. The problem then is this. It's like, what is this action? It can't be a T type because you don't know what the T type is. And you can't leave it open. It's got to be closed. So how do you actually do this? I did not think this through. I did not think this through at all. And that's biting me. I mean, I want to do something like this, but I think, hold on, I got to go get my cat. It is his tradition in the morning to come in here and say hi to me in the morning, right? Yeah. Yeah. You're a good kitty. I've shown this kitty before. His name is Tank. Can you say hi? No, you can't. Okay. It's cute. He comes in the morning and says hi to me every time. Okay, I think what I'm going to have to do is casting. So we're going to need something that's like an action or just a delegate and a delegate, and then I got to cast them. That's really the only way I can see doing this. So like a read-only dictionary of a type, and then a delegate pair customizers equals new. Okay. So you pass that in eventually, but then we want to say if this dot customizers dot try get value. Yes, exactly. That's what I want you to do. Else throw new not supported exception. We could say no custom serialization support was found for the given for type. And then we could put in here type of T-type, full name, whatever, doesn't matter. But now if we do have this, what we want to do is return, and we're going to do that. And we're going to say here, we're going to cast it of an action of a T-type binary writer customization item. Except we don't want that. We want, can we do out var serialize var deserialize? No, you're not going to be that smart, are you? Wham. Let's do that. Let's grab this serialization. And then we're going to do that. It's equal to serialization, which we can. And then you can say serialize here. And then we'll do a func of a binary reader T-type as the cast of deserialize. And that's it. And of course this is going to work. This would never not work. And that's all you need to do. And then you need to pass in the actions and the funcs. Now, this is horrible. Don't get me wrong. This is absolutely horrendous because there's no type safety here. You have to remember that the first pair that you're of the value in the tuple is of this type. And then you have to remember that to create it. I'm babbling here. I'm just struggling with the fact that what you have to give me is a public custom serialization dictionary T-type of customizers equal to this there. And that's just awful. That's just horrible. I don't like that at all. I don't see, though, how I can do it such that you could create it in a type safe way. The thing underneath the scenes would allow you to add them in a type safe way. You know what I mean? You have to have some way to like custom serialization builder. You want to build these based on different T-types, which again is horrible. But that's kind of what we want. The thing I don't want is for somebody to have to, I mean, the thing is from an IOC standpoint is that I'd have to make it so that you could register multiple of these, like having this, or really this and this be of its own type. And then you'd register all of those, and I would have to find the right one. Now, at the same time, though, what I would also need to do is see, that's the thing, though. I don't know how many you would have. And what I need to have passed into my contexts, I can't have like a list of them. I don't think the IOC container would be smart enough to say, give me all of the registered implementations of this type. I don't think it can do that. I could be wrong, though, because if it could, then I could get that list, and then I could say, okay, find in the list essentially the thing that matches the type that you're looking for. And then you could return the right thing, if that makes sense. It's messy though. And I just don't know off the top of my head if the container would allow you to do that. So given all that, even though this is awful to look at, it would work, because I would ask for this. I'd say try to get customizations of this T-type. And then assuming you did everything right, these casts would work. It's just there's no enforcement of it, and that just gives me the willies big time. But it's either that or can you do that? Let me just look real quick. So .NET. Sorry, I've got to look something up here. What is that called? Service collection. So you can do service collection, list of registrations. Can you do that? How to register multiple implementations of the same interface. How do I sell services? Well, yeah. Yeah, I didn't really see anything in there other than you have to like kind of register your own factory pattern around it, because there's oh, wait. Gets the service object of the specified type. Gets service of type T, an object that specifies the key of service object to get. Who wrote this? I mean, this is sort of close to what I want, but I want it to actually be, yeah, it's not really what I want though. And there's a keyed service, but that's just, yeah, the key is the type. That's not really what I'm looking for. Get services, get enumeration of services of type T from the service provider. So I could, yeah, but that's not, well, maybe. Because what I could say is, okay, maybe I am overthinking this. Maybe the right thing to do is, yeah, you register a custom serialization of, yeah, maybe that's the ticket. The only problem with that is I need to take a reference to the container. You know what I mean? And I don't necessarily want to do that. Let me just illustrate it. This is the thing I really want. Okay. Well, I guess it could be that. No? Things? Stuff? Why don't you like that? Oh, I'm overthinking it. Yes, it would just be this. And then you'd have public custom serialization where you pass in, you don't need the type. And what you pass in is that as a specific serialize, that as a deserialize, that, and then you don't need this and you don't need that, and then you have a private. Okay, I think I'm finally getting my head around this. Read only that, and then you have a private read only that, and then this becomes, no, get out of my way. This dot serialize, this dot deserialize equal to serialize and deserialize. Okay. And so now what you could say is you could have a public void write to a binary writer. And what that would do is take this dot serialize. No. You need the, yeah, T-type value. So you'd say take this serialize value writer. and then you need a public T type read on a binary reader, and that does that. Perfect. Okay, and so then what I'm thinking you could do is you would register all the types that you need in your container. And then what I would do is have, where did I just see this? I could make something that has a custom serialization resolver. And maybe what I do is I have my own extension method that you need to add to the container. And what that would do is add that resolver. I would then pass that resolver in to my contexts and then say resolve of a given type, because I would know what that type is. Would that work? I think possibly. I think maybe, because I think this is the one. Yeah, geez, so bright. Go away. I did log in, sign up, go away. And yeah, this sucks. I would not do it this way. But I think there's some way I could say, given a type, then see if that contains a redo make generic type on this type. And if it does, then you'd return that. Otherwise, you'd say key not found exception or something like that. And that would mean that you did not register one of these things. So I think in the next episode, I will put that into place and see how that works. And I think I'm getting better. I definitely like this. I'd much rather have this, because this is what you'd want to have. And with all the type safety and everything else, the way I was going to do it was going to be horrible. And it's funny when I go back and edit videos that I've done and I see myself going, like, I know I've already finished and gone down a path and made it happen. But when I go back and I see the videos where I'm struggling trying to make something work, and it's like I want to strangle myself through the screen, because I'm like, did you not see this? How obvious it was that you should have done it that way. But sometimes it takes a little bit of time to get to a solution. So yeah, I'll keep working on this and see if I can get something that finally does work. Thank you all for watching. Leave comments and questions below. See you in the next episode.